Okay, these are notes 1.1, starting us off with a lot of review here from what you've learned in the past. So we're going to start off with different kinds of numbers. So we have our real numbers and we have our imaginary numbers you learned in Algebra 2. So when you first started counting, with your natural numbers. Those natural numbers are the set 1, 2, 3, 4, and it keeps going and keep going and going. Then we have you eventually learned the number 0 when your parents said, no, you can't have anything. So 0 is included in 1 and 2 and 3, etc. as a whole number. Then eventually you learned there were some negative numbers. So integers include our negative numbers, some negative numbers as well. So -2, -1, 0, 1, 2, etc. Those are the integers. Our rational numbers is any number that can be written as a fraction, basically. So if we have any number p over q such that p and q are integers. Okay, and you also know that q can't equal 0 because you can't divide by 0 there. So basically anything that can be written as a fraction is a rational number. An irrational number is x such that x is not rational. Okay, so let's talk about these a little bit more. If I have the number pi is 3.141596, blah, 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 and it keeps going and going forever and ever. So that number, it doesn't have any repeating patterns to it, is an irrational number. If I have like 1.3 repeating, that can be written as 4/3, which if it can be written as a fraction is irrational. So basically if you have decimals that have a repeating pattern to them, they can be written as fractions, which make them rational. Irrational numbers don't repeat and keep going on forever. Then in Algebra 2 you learned, okay, if I take the square root of a negative number, I can't really do that because the number times itself is going to equal negative. So we talked about imaginary numbers. So 2i is an imaginary number. If you have a real part and an imaginary part, so 3 plus 2i, that's called a complex number. So you learned about those a little bit then as well. So if we look at these, let's classify these. So if you have -3 is not a natural, not a whole, but it is an integer. So it's an integer. And anything that is an integer is also going to be rational and real. 0.6. Okay, 0.6 can be written as a fraction, so that is a rational and a real number. Cubed root of 10. Cubed root of 10 is like 2.15, and it keeps going. So that cannot be written as a fraction. So it's not part of these. It's going to be an irrational. And irrational numbers are still real type of numbers. Pi also, 3.14159, etc., is an irrational and a real number. 0, not part of our natural numbers, but it is included in the whole numbers. So it's whole, integer, rational, and real. -5/8 can be written as a fraction, so rational and real. 2 plus 3i is a complex number. And 10,321 is part of our ... natural numbers. So natural numbers are also whole numbers, which are also integers, which are also rationals, which are also reals. There are symbols for all these things, but we're not going to worry about those today. Graphing the set. So if we create a number line here, okay, and we put these in here, -2/3 would be about right here. 0 is right here. Square root of 2 is like 1.4 something, so about right there. Square root of 5 would be, square root of 4 is 2, so square root of 5 would be a little bit over 2. And pi is 3.1, etc., and 4. So you can plot on a number line. If you remember your Cartesian plane, this is our x and this is our y. This is our x, that's our y. So if our x is a 3 and our y is a 4, we have this point right here, which is that. Talking about our quadrants, this is quadrant 1, quadrant 2, quadrant 3, quadrant 4. Order of operations, PEMDAS, or as I learned it, please excuse my dear Aunt Sally. So PEMDAS, and we do parentheses first, exponents, multiply and division from left to right, and then lastly adding and subtraction from left to right. So if we work these out, we have to do inside the parentheses here, so be 3 and negative 5 right there. Next we want to square those, the exponents, so it would be 9 and 25, which is the square root of 34, and I'm fine if you leave it as a square root of 34. If you put it, you want to get a decimal form in Desmos, you can do that as well, that's fine. This right here, this fraction bar is kind of treated like a parenthesis. We're actually going to do everything up top and everything at the bottom, and then we're going to do that last. So it'll be 64 minus 8 plus 3 on the top gives you a total of 59, and on the bottom, inside the parentheses, that's negative 7. And if you remember absolute value by definition is how far away it is from 0. So negative 4 is a distance of 4 from 0. Don't do negative there. You want to do the absolute value first, which is 4, and then you can subtract that after that. So, and then 49 times 2 minus 4 gives you an answer of 94. You can leave it as a fraction or put it as a decimal. Not much here simplifies, so you could just add the top, leave it like that, or if you put it in the Desmos, it's approximately negative 7.04. Okay? So the next thing we want to talk about is the distance and midpoint formulas. So the distance formula is derived from using the Pythagorean theorem. So the Pythagorean theorem, if you remember, is a squared plus b squared equals c squared. It really doesn't matter which is a and b. So a squared plus b squared equals c squared. So if we think about this, let's derive that formula. So if we make this right triangle right here, and let's make this the a, and that's the b, and that's the c. It really doesn't matter which is the a and the b. But anyway, so if we think about a squared plus b squared is going to equal c squared. To find this distance of a, notice this is a certain x and this is a certain x here. To find this distance, I can take the two x's and subtract them. And find the b, this distance here, is this y and this y. I can take those y's and subtract those. Okay. Then if I want to find c by itself, opposite of squaring is to take the square root. So I'm going to find the square root, x minus x squared plus y minus y squared equals to c. So there's your distance. This is basically your distance formula. If you want to know the distance from there to there, you can find that. And you might have seen like 2's and 1's in here in the past. It really doesn't matter the order, because if you subtract numbers and square them, they're going to give you the same thing all the time. So I want to find the distance between these 2 points. Okay, if I do x minus x squared plus y minus y squared, I know a lot of mistakes were made right there. Remember your work with signs there. So this gives us negative 11 squared and 6 squared, which is 121 and 36, which gives you the square root of 157. I'm fine if you leave it like that, or it's approximately 12.53. Okay, and then down here I have 3 points. I want to know if these 3 points make an isosceles, equilateral, or scaling. Remember, isosceles means 2 sides equal, equilateral 3 sides equal, scaling that none of the sides are equal. So I like to get a visual of it. So negative 1, right here is x. Y is at 2, 3. And z is at negative 4, 3. Okay? So basically you have to find all of these distances. So let's just say I take x and y. The distance of x and y is going to equal the square root of negative 1 minus 2 squared plus negative 1 minus 3 squared, and that'd be 3 squared, and that would be 4 squared. 9 plus 16 is 25. Square root of 25 is 5. Okay, so I know that xy, this distance right here, is a distance of 5. You would then have to find the distance of xz and zy. I'll just tell you that those come up to be 5 and 6. So it's not scaling. We have two sides equal. It's not equilateral because all three sides are equal. It is isosceles with two sides equal. Okay. Next, our midpoint formula. If you have two different, say you have two different test grades, if you want to find the average between them, you would just add them together, divide by 2. It's the same thing here with the midpoint. If I want to know the midpoint between 2 points, so say I have this point and this point, if I want to find the middle between these two, the x, this has this x, this has this x, the middle would be somewhere there, right? So all I'm going to do is add those x's together and divide by 2. And same with the y's. If I have a y here and a y there, if I want to find the middle of those, I'm going to take 1 plus the other y and divide by 2. Right, there's your midpoint formula. So if I want to find the midpoint between these two, so it would be 8 plus negative 9 divided by 2 for the x, and negative 4 plus 6 divided by 2 for the y. And if I work that out, that's negative 1/2 and 1. And it wouldn't be a bad idea if you wanted to graph the points. One would be up here, one would be down there, and the midpoint's right there. So you can get a visual and make sure it's right. Okay, so this one's a little bit different. Here we have that 2, 4. That is the midpoint. So this is my midpoint right here. It's given to us. And D is at negative 4, negative 8. So D is down here somewhere. And I want to know F. So visualizing it, I know that F is going to have to be somewhere up here. So if I think about this, I know that F is going to have an X and a Y to it, which I'm trying to find. So I know that this X plus D's X, negative 4, divided by 2, is going to have to equal my midpoint X, which is at 2. If I multiply both sides by 2, I know that X minus 4 equals 4, and 4 over, I get X equals 8. So I know that this point over here has an X of 8. I'm going to do the same thing for the Y. I know that this Y plus the Y down here, which was negative 8, divided by 2, is going to equal midpoint Y. So multiply both sides by 2, and add the 8 over, I get 16. So I know this is the midpoint of this point and this point, which would be 8, 16. Okay, you can also kind of think about this in real life. If in 2002 the average tuition was a little over 4,000, and in 2008 it was this much, if I want to know halfway between those, I can just kind of average those together. So 2002 and 2008 divided by 2 gives me the year 2005, and 2002 was 4,081, and 2008 was 6,585. The middle of those two numbers is 5,333. So that would be my estimate between the value for 2005. Now in actuality, it was this, which isn't too far off, but it's kind of estimating. That is all of 1.1. I'd like you to do the homework at any time. Come back to this, pause it, do correction, do whatever you need to with this video to make sure you understand the material and get the homework right. We'll come in class and ask any questions then. Have a great day.